All right, so here I'll just go back over that.
Were we supposed to get on quick parts?
I forgot them, so I'll give them to you tomorrow. Remind me if I forget, then I'll send somebody to get them. But I have planning tomorrow before 5th, so I can go with them. So again, we're going through and we're doing we're doing synthetic division. I forgot to start the recording, so I'll catch you up. We said that the m that's circled in red, that m goes into that 10m cubed, and it goes into it 10m squared. That's how we got the 10m squared up top. We said whenever we divide, we only use the first term. So we only use this and this when we divide. Then, though, when we multiply in the second step, we have to multiply times everything over here. That's when we finally use the +1. That's how we got the second line down here, 10m cubed plus 10m squared. That's because we multiplied 10m squared times m plus 1. So now we're just subtracting it out. We said make sure you remember that you are subtracting both of those terms. I kind of like doing it this way. If this helps you, again, I don't care how you do it. Just write, because really, since these are like terms, so these are the only two things you can combine. These are like, oh, you can't see this on the recording, so let me. Here, I'll do this and I'll get rid of it. These are like terms. These are like terms. Those are the only things I can combine. So I can kind of treat them as two separate problems, really. Because I can't combine the m squared and the m cubed anyway. So I can just sort of treat them separately. So I'm really just saying, okay, well, that's 10m cubed subtract 10m cubed. I come down here now. I could even write that on the side. 10m cubed subtract 10m cubed. Whatever you got to do to make sure you don't make that other mistake. Well, that's 0m cubed. I get 0m cubed. Now I do the squared separately. Well, that's m squared subtract 10m squared. Well, that gives me what? What'd you get there? Is Hannah, what'd you get? Do it. Put it right there. What do we get for the m squareds? Oh. Yeah, m. So again, we're saying m squared subtract 10m squared. Well, that's just combining like terms. So actually, I'm going to write it over here. So that's negative 9m squared. Now what do we do? Yeah, now we can go ahead and bring that down. Well, what are we doing though? Where are you getting that from? What are we doing? What's the math we're doing? We're dividing. Now we're back at the beginning. We're starting all over, right? We're doing the division, remember? Because the reason why I want you to say division is, what did I say when you do the division? What do you focus on?
The leading coefficient.
When we do the division part, we just look at the leading part, right? Yeah. So we're just going to focus on the leading part. I'll go back to red. So the leading part is this. And still that m. So we just, for the division part, we always just focus on the leading term. So how many times does m go into negative 9m squared? Yeah, negative 9m. It's pretty easy when there's no coefficient out here. It's pretty easy. So now when we do the multiplication, though, again, now we're just repeating. We have to multiply negative 9m times the entire thing. So what do we get? And so now here's one of the tricky pieces. Correct. This is negative 9m squared. Subtract negative 9m squared. So it flips to, wait a minute. What did I do wrong? Oh, wait, I forgot the negative. So it's negative 9m squared plus 9m squared. So that just cancels out and goes to 0m squared. And then I'll scroll down a little bit. I'm now saying negative 14m. Subtract, and I have to include that negative. Subtract negative 9m. So what did you get for that piece? Negative 5m. Again, just be careful, because it changes your whole answer if you miss one of them. Because again, this will flip to plus. We still have negative up there, so it's negative 5m. And then last m will go into negative 5m. How many times? So that's negative 5. So if we multiply it back through, unfortunately, it looks like we do get a remainder. So we have a remainder, I guess, of negative 5. So we're. Oh, shoot, my fault. So still a remainder, though. So now that we subtract, so again, that flips to positive. So I'm not going to write it out again over there. So again, we do get a remainder. I was hoping that was going to come out to be nice round, so we could do the other steps. We'll find one where we can do that later. All right. So again, the way I want you to write the remainder, and I don't like the book does it a little bit differently, and so does the worksheet that I'm going to give you. If it's a negative remainder, they change it into a positive remainder, and sometimes that means you got to change the signs of the denominator also. I'm not even going to worry about it. I don't care if you just do this. If it's a negative 2, you just say plus negative 2, and then I want you to put it as a fraction for the remainder. So we're not going to do the little, just write the letter R and then the negative 2. We're going to write it as plus, because some of the problems, they actually have you multiply it all back out and then add this little fraction in to make sure it gives you the original polynomial. I don't think I'm going to do that, but you happen to see that somewhere else. And you may not realize how you do that if you just wrote remainder like R negative 2. This way it would work though. You multiply this out times that, and then you added that in, you would get the correct answer. Well, actually, you wouldn't do it that way anyway. You would actually multiply all of that together times that. All right. Any questions on that? So you're going to do some practice on that. And then I'll find a couple we can do where we'll finish it all the way out with no remainder. So these all have remainder. Remainders are all. And there's not going to be a whole lot of difference between all the other problems on there. Like I said, only it does say do it on another piece of paper if you can't. Oh wait, no. So if you can't fit them in, I mean, I don't care if you do all of these. Like you can pick and choose, like do one, skip one, and then go to the next one. So you have more room if you want to just do it all on this one sheet. It's plenty of problems for you to practice, so you don't necessarily have to do all. Oh, the answers are on the back page. We're already solved that. So yeah, you can check your own answers. And like I said, I'll find some we can do that we can go all the way through and solve for 0 on. I'll leave that up if you need to look at that.
Nice and smooth, it's so quite loud.
What, toast up?
Yes, 75.
Oh, yeah.
$75 for a cup?
Yeah.
Yeah.
That's crazy talk.
This was a gift.
Turn on. I swear you could get a very cut for that for like 25.
Well,
Is it gonna give someone a gift?
Yeah. I'm more worried about you than I am about it.
I know, cause like there was this girl on TikTok whose car like caught on fire.
it's gotta be true. On TikTok, wow, gotta be.
And Stanley literally like paid for a new car because she like made a video about how like her. I don't like her. She's kind of cool.
Hey, if you realize, hey,
To get a new car because her car caught on fire. She went
Probably
viral.
think the whole fire.
You are such a pessimist. You can't just let me.
Realist, big difference.
Duh.
Realist,
Can
right.
I go to the bathroom?
You've been on your phone the whole time, do something.
I have not. I participated in this.
Yeah, that's why I didn't tell you about it then, but now you wanna go to the bathroom, do something first. It'll take you like 2 minutes,
I'm just gonna pee in your
and
bed.
you make me wanna.
What?
When you're on the softball. field.
I'm good.
I'm still gonna go boo. If you make a mistake, I'm like, yeah, you should have done your math today.
I'm banning you with the softball.
And you know, actually, I cheer loud.
It's-
That was before, well, I mean, basically.
People like are really legit about not wanting to pay for tickets, so we had to put up a screen on the side facing.
Oh, yeah, no, I know what you're talking
Because
about.
people would like families would like sit out there and like watch like the outfield.
They do that for football too, they sit.
Yeah, they sit.
On the side, they watch all the way there, that's a long way. That's a long way to still try to see the field.
I'm like, absolutely not. I will just pay $7, $5, $7 and 10 cents.
I mean, I will say, if you got 4 or 5 people rolling up though, and you can see from the just outside the fence. I probably would. Oh, I was gonna print that out. That's awesome. All right, I found some that we can do that'll work all the way through, and so I'll go grab that.
Oh, well, this one.
So,
Wait, is this right?
I remember these things like this early.
Negative, minus, and negative, it's not positive, right?
Yeah.
I fucking told you. I think like, I thought this was really good.
No, a negative and a negative is a positive, no matter what you're doing. Because you're subtracting.
Oh, shit, yeah. That's yours.
I put 15 minutes. Oh my.
Did you?
Yeah, because I said I wanted to yell at me when I got home. She said when did
I care about you, that you can. I'm here just for school, so, yeah. Say it to you about it. Okay.
You're not my family.
I'm not in the bachelor's.
Wait, so I'm confused.
So there's.
I know, but like, so now it's one M, so it's just M. So it'd be. What's that? Wait, the one M, break down the one.
Yes.
Yeah, so now, we're just, what's your number, figure that.
Oh, is that holding anybody from bathroom?
Oh.
Oh. Yeah.
I have to wait even longer?
Oh, wait, you would ask. Totally fit, if I'm holding anybody in those back there. So I do something to that. No, I'm fine with you going now. I mean, you should have one done by now at that time. I hope you finished
I'm
one.
almost done.
Happy birthday. Peter's not here. Oh, yeah.
That's why you said that.
So does anybody know if Rachel got her birthday present? I didn't give that birthday present out there. I'll ask her.
You can be my birthday, then.
When was yours though? October?
January 2nd.
Oh, you got one in January?
That was during the.
I don't have that. I don't have the January list. I normally do that. But I mean, if your name's up there, I give it to you. I don't remember if she got hers was back in November. And sometimes I give them in the months. I feel like I did get her though. All right.
He made it right.
That's right. She didn't want one, and she gave it to him, and I said, "Why'd you give it to him?" All right, so she's good. Good memory. Nathan's not here, although I think I gave him one too. Janelle's actually waiting also. So after Janelle. I mean, we got plenty of time. We're practically done with the lesson. I'm gonna do one problem where we can work it all the way out and like get factors that we can solve. Should be a pretty simple quiz if you guys practice this. I'll have to, let me see if I can tell you exactly what's gonna be on there from the last chapter. I think the only thing I'm gonna add in is how to create a polynomial from a solution. Okay. Yeah. Oh, which is so super simple. And you just the factor would be x. Then you flip the sign, so plus or minus some number, whatever the number, the answer would be. I would, the only thing that could be tricky, and I probably will do this because I gotta make it at least a little bit difficult. If I put in that x equals 1/2. Yeah. What would you need to make a factor? We'll do this as an example. I say x equals 1/2 is the solution factor. I don't want you to write x subtract 1/2. I want each fraction to be a factor too. Not exactly, don't get two in there, but it's more than that. That. No, it wouldn't be a less than or greater. We'll do that later. Just remind me. We'll do that later. So keep practicing this for now. Let's get all the polynomial division stuff down. And then I'll be happy when I do the next problem. We're gonna do some.
It's showing me the process.
Oh, it's frozen me. Let me go ahead and do this so that I can stop the recording. Otherwise, I'm just recording a bunch of dead space. And I want to do one more thing before I stop it. All right, so go ahead and pause what you're doing. I'm going to just work this one out. I'm making copies, so you have a bunch of these practice things also. Here's the only other thing from synthetic division, at least. The only other thing I'm going to put on there next Monday is if we start with a polynomial. And I'll say it probably just like this. I'll say find all of the factors, or if I'm sorry, find all of the zeros. And I'll say one factor is given. So this is the word right here. Looking at one of your problems, it'll just be a different polynomial. What do we do? First step. Your guess. Well, you should only be thinking there's only two options. That would be one of your options. But, and we can do that. We just can't really do anything with that yet. Because what do we need ultimately? Like, we've got to know what all the factors are, right? I would just do the division first. It won't hurt you as long as you understand you can't. So if I do this, I can't do anything with it. Right? Well, I could. I do know. You should know one fact. I mean, you should know one answer. One zero. What's 1 0? -5, right? Because I know this, if they're telling me this is a factor, well, ultimately, if this is a factor, I could set that equal to 0, solve for x. So -5 is 1 0. Because I know that's a factor. I have to figure out the other factors, though, which how am I going to do that? That's when the synthetic. So I just go ahead and do the synthetic division first. Then I would just go ahead and set those equal. Again, as long as you understand, at some point you got to divide and get all the factors before you can figure out all. So with that in mind, I'll just rewrite it again. X cubed plus 9x squared plus 23x plus 15. All right, so now we can divide that by x plus 5. I want you guys to try to solve that out. And again, if it's telling you to come up with the zeros, that means I hope that means we can factor the quadratic polynomial that we still have left over. If they want us to solve it some other way, like by the quadratic formula or something, then we can't really do it, but I don't think that's the case. I'm hoping it's going to be able to be factored. I'll give you like a minute or two to work through that, all of it, then I'll let faster. No. It works. I'm printing this out. Or copying it. Actually, I'll go grab those, and by the time I get back, we should be ready to. There are some in the book we can practice also, and obviously they're odd ones, but yeah, the answers are on the back sheet of these. So you have a bunch of them with problem there.
That's the same thing. So what I did is. That's what I'm doing. I factored up here too.
Here is another packet that has problems that you can work all the way out and get like solved for the zeros. Are you not sure how to do any of this stuff? Oh. So the only other type of problem that'll be on Monday is how to take a problem, and if I give you the zeros of the polynomial, you have to create a polynomial that has those zeros. And that was one of the simplest things we did. Yeah, you find the well, first you gotta find the factors, which you would do by doing, the opposite of whatever the zero is. So the 0 is -2, factor would be x plus 2. Factors out. I don't know what the difference. We're gonna do it in a second. There you go. If you don't, I give you one all. Yeah. Get on one. Yeah. Anybody not get one of this pack? One of these. All right. Let's go ahead. It looks like some people are wrapping this one up. So we'll go through it really quickly so you can see practicing. How many, again, on the division part, we focus on what? Yeah, the first term, right? So when we're dividing, we focus on just the first term. So how many times does x go in x cubed? Squared, right? You should all have this one done. So now when I multiply it times both pieces. So that gives me x cubed plus 5x squared. Now I'm subtracting. So that subtract that is 0. That subtract that. 4x squared you should have gotten. Now we can bring down the 23x. Now we start all over again. We start dividing. X goes into 4x squared. How many times? 4x, right? Don't forget about the x. Again, when you multiply it back out, if you don't get that first term, you know you did something wrong. Shouldn't really mess that part up. X, 4x times x is 4x squared. 4x times 5 is plus 20x. So now we're subtracting out. So this subtract that, and then subtract that. 3x. Now I can bring down the plus 15. So how many times does x go into 3x? So plus 3. So if I multiply 3 times that, I get 3x. 3 times 5 is plus 15. No remainder. This is my other polynomial. I know that's a factor. Now I just have to figure out what are the factors of that. So how do I factor that out? How do I factor that out? What do I focus on when I factor? First and last. What's the only way to get x squared? You know that's the leading term. What's really the only way to get positive 3 and to have a positive here is what? Only, yeah, 3 and 1, right? There's no other factor. It doesn't matter where you put them because it's all addition. So that's gotta be. So then the last step would be now, if this is a factor here, told us that in the beginning, that's a factor there, that's a factor there, and I say find the zeros, what does that mean I do to solve? Set each one of those to 0. So if we set that to 0, one of the zeros has to be -5. One of the zeros has to be -1. One of the zeros has to be -3. Again, all I did is I said x plus 5 equals 0. Well, then I subtract 5 from both sides, which gives me -5. X plus 1 equals 0. X plus 1 equals 0 just means I subtract 1, subtract 1. X has to equal -1. X plus 3 equals 0. Subtract 3, subtract 3. X equals -3. That's how I got the -5, -1, -3. Just set each of those equals 0. Is anybody still writing that? Actually, I'm not going to write all of it in. I'm recording this anyway, so yeah, doesn't matter. We have to go back and look at it. So here's the last. Not normal. I mean, if somebody yells and
Okay.
like they might hear like noise in the background, but unless you're really talking loud, they can't understand what you're saying. I mean, I had somebody yell out something inappropriate, and I had to like then re-record it all over just like a one knucklehead. So if I tell you to create the polynomial, that is the only other problem you're going to get Monday. And I tell you these are the zeros. What do?
Big factors.
So the zeros come from the factors. That would be the step right before. So we got to come up with the factors.
X minus 7.
And it would have to be the opposite sign because that would be add 7 and add 7, which would give us x equals +7 for that 0. I don't want you though writing x subtract 1/2. Nope, that would just be -2. If I said x plus 2, I'd subtract 2 and subtract 2, that'd be x equals -2, which is not x equals 1/2. Nope, I don't want you using decimals. I want you using whole integer coefficients or constants. Now you gotta think. I want to make you think a little bit, even though this is pretty.
I
Nope.
don't like fractions.
I know, that's why I'm making you do one.
You did this on purpose.
Oh, yeah, absolutely. It'd be too easy to just say X track.
Unsolvable?
No, it's
Is that
totally
it?
solvable.
Is that an answer?
No, I mean, it is, but not in this case. How would I get X? Actually, I don't even need that. So I start with X, right? My end result is I want to get to 1/2 instead of 0, right? How would I make that into something on the left-hand side and 0 on the right-hand side? How do I make this
The
0?
only thing I can think of is subtract one.
Yeah, there's another way to do it. If you remember the proportions thing we did, what we do with proportions?
Last question.
Hmm?
Last.
Yeah, I had last semester.
Then no.
We could probably do it that way. There's another way. I want to get nothing on the right side. Nothing to be over there, right? So what do I need to get rid of? Think of them as individual numbers. So how do I get rid of just the 2? Multiply by 2. So times 2 times 2. How do I get rid of the 1? Ta-da. Actions. And think about it, if I solve this back out, like if I set that equal to 0, wouldn't I add 1 and then divide by 2? I mean, once you do a couple of them, you'd be fine on that. Again, I don't know if any of these practice problems have you do that, but you're bright, you can figure it out. You're gonna have to think a little, I mean, otherwise this quiz is too. I'm giving you a quiz. So easy. That. You graduate with the
No, the school wants you to graduate. Yeah.
I don't want the failure. I want you to be successful, which doesn't always have anything to do with your grade. Grades are test scores, a little bit, like I don't mean my test scores, I mean like ACT, SAT, those have a little more to do with it. I just learned that the ASVAB has a lot to do with that. I didn't even know that. We're trying to know that.
Yeah, this I probably.
Yes.
For that.
Are you doing ASVAB? Oh, yeah, as half of that,
No, it's
although
all math.
you'll do well because you actually, I was gonna say, yeah, you're, one of the big pieces is, it's called arithmetic reasoning, which is not like specific math stuff. It's like logic. If you're good with logic, which you're good with logic, that's a big part of the ASVAB. Actually, it's, what's the other, there's a big ASVAB, then there's like
Yeah, there's.
AFUT or some weird.
Yeah, it depends on the branch and what they like, what other special things they want to use.
Yeah, because they said
Like-
the,
Cause I'm doing Air Force, they don't take straight from my ASVAB score, they take from my MAT score. Which is like, yeah, that one is like, it's like,
and yeah, different branches definitely have different requirements. It's
yeah. I
harder
mean,
to get into probably Air Force than it, no offense to anybody that they don't like. Okay, well, you know Emily Campbell? She was saying, well, she says she's horrible at math. She's not. Just, none of you are horrible at math, you would not be in this class. Because kids that are really struggle with math started in Algebra 1A. None of you were in Algebra 1. None of you were probably in Algebra in high school. Probably all started in geometry. So I would say out of a freshman class, 60 to 70% of the freshmen start in Algebra or Algebra 1A. So
That's so
that means you were in the top 30%, just immediate, at least immediate. You started in Algebra 2, you were even higher. Oh, I'm gonna stop the recording right now. So again, that's the only, so how do we do it now? Now that we came up with the factors, I didn't finish. Let's finish it off. What do we do to finish it off and create the polynomial? Yeah, we just multiply, right? So if I know those are the factors I want, I would say, all right, well, that gives me 2x squared. Negative 14x, subtract x is negative 15x, and then positives. So that problem, the only tricky part would be how to handle
Okay.
fraction, and I don't want any fractions in the final.
Oh, are you doing the fraction?
Yeah.
Okay.
Why would I give you the fraction here? Again,
I thought you were just like testing it to see like if we could figure it out, but you were gonna make the test a little bit easy.
if- I'm giving you exactly what you need to do on
Want
Monday.
me to like ship out on time.
No, I'm giving you exactly what you need to know how to do. Should not be an issue.
Make my brain hurt.
All we do is multiply by 2. Just treat these as individual numbers. Don't think of it as 1/2. Think of it as a 2 on the bottom. Get rid of it. And you'll be left with the 1. Get rid of it because you want 0 on that side. Basically, so easy. It's too easy. Should make it hard.
I know, I can. I love.
All done for the day?
Whoa, this baby was eating that, you know how I do it.
Hey, you got everything you need, so. Oh, I didn't start the recording, did I? I don't understand why it does it sometimes.
Yeah.
Wait, there's a drill facility right now? Hold on.
I do.
Oh, it's just saying that I need to try, so I think most of us are the same. That's pretty good.
Or just a drunk.
Worlds.